We are going to import a Parasolic file for the Newton exercise. Click on Documents and click on Open, and make sure the file type is Parasolic, and of course make sure you download the file from the web page and save inside your working directory, and select the file inside the Parasolic file inside your directory, and then click Open. And make sure the MM. Make sure this is not selected. The part is in MM, and make sure also we are choosing C-axis horizontal lead, and then click OK. If you want to rotate the model, you can always press middle button of the mouse, and if you want to do a dynamic zoom, press Ctrl key with the left button of the mouse, so you can examine the model. And once the part has been imported, the stock will be automatically string fit. Yeah? You can see now the part diameter is 222.542. So I'm going to increase to 250 as the stock, and I'm going to leave let's say 0.8 mm in front of the stock, and at the back the length is -98. I will extend it to -150. This will be our stock for the machining. For the clearance, we'll set we're not going to use the auto clearance. We'll set this value to 275 for the X, and for the Z we set 3. For the tool change location, we're going to set it 300. This is where the dollar or tool will change at these locations. And for the lead tool, the shank we will use 1 inch, yeah, and also the milling class, the milling holder. For now, we use a Cat 40. After setting the stock information, then click Save to save the file. I'm going to save it as MM Revolver VNC. Save it, and then close this. By standard, a terminal in Gibbs cam will have 4 standard coordinate systems. To access this, you can click on the coordinate systems. Over here you can see we have a ZX plane. This is the default lead plane, lead working plane. And we have XY planes. You can use a view to change the ISO view. XY planes, this plane, ZX, XY, and HY, the back plane, and also the Z plane, ZY, YZ plane. For lead, we'll start working at the ZX plane, and click Home to go to the home view. Now we're going to do some machining operations, do some machinings. We will on this tool to show the tool list and the operation list. Over here is the operation list, and this is the process list, and this is the machining functions. What you see here is the lead functions, and if you need a milling functions, you can click on the mill, and this will show all the milling functions. Let's go back to lead. We're going to create the first tool by double click on the first position over here, T1, and we're going to choose the 80-degree insert and 0.8 radius, 12.7 inch square diameters, 4.7 thickness, 4.76. We'll use a holder and carbide insert. This is our first two. Now we're going to create our first turning process, that is the facing operations. I'm going to drag the first two into the process list and a contour operations into the first process. Now make sure it is you are using the front face, the clearance is okay. The material clearance, we're going to machine material only with a clearance of 3 and finish stock of 0.2, and yeah, this setting is all okay. Maximum RPM 3005. Please make sure your setting is same as mine. Next, I'm going to show you how to use a GibbsCam 3D profiler, this icon here, to section the 3D part and get the part outline. You can see here, GibbsCam profiler will automatically project your 3D part and get the maximum diameter out of it. It makes sectioning line easy. I'm going to go to home view, and the features that I'm going to select is only this line, so I will pick this line and right click, and I'm telling GibbsCam that I want to just cut these single features. So just right click, after you select the line, right click and select single feature cut, and then I can drag the start point here, and I will move the end point to the 0 to make sure my cutter will end exactly at the X0 for the facing operations. If this is okay, just click do it. This is the finishing. This is the facing operations. The dotted line is the rapid motions. The orange line is the cutting motions. You can see the cutter is starting somewhere over here at this distance. This is the to change location. It is set over here, this location. Now it's setting at 300 diameter and the Z300. If the first facing operation is okay, and you might need to use this this facing process with this two in the future. In GibbsCam, you can always save this operations or this process into your library. How to do that? Just go to process and select save. Of course, make sure you highlight your operations that you want to save, and then you can key in your own name. Put inside the somewhere over here, my facing operation. Save. So in GibbsCam, you can always save your operations for future use if needed. Before we doing the roughing, OD roughing, make sure you already download this cutting processes file from the web page and unzip into your working folder. Inside this cutting processes, we have a name called Revolver. Under it is all the safe cutting operations of the Revolver. We're going to use this one. Okay, now before we create import the process, cutting process, we make sure the second operation is selected. Delete the first process. This is not wanted, and go to process. First of all, set the directory of the cutting process. So we're going to select this folder, cutting process, as our default directory, default folder for the cutting process. And now I'm going to load the roughing operations. Go to process revolver and select the second one, rough OD. You can see after I load, the process is being loaded out and is using the same tool number 1. The cutting process, we're going to use the default one. No need to change anything. And of course, make sure this X minus is unselected, because we're not going to machine the groove here for the roughing operations. So after you load the process, next step is to select the geometry. I'm going to select this arrow here, machines inwards towards Z minus directions, and I will relocate my starting features over here and then extend that features out of the stock. The end features I will extend until here, and then I will move the end point by a amount 3 mm. To do that, you just right click and choose the smooth start end point and key in the value, and you got the extensions. After you select the geometry, if this is what you want, then you just click do it to have the roughing operations.